Right, so these are the four shapes. A straight line, a circle, right? Straight line, a circle, and ellipse and a parabola. Parabola looks like what? A maximum, right? Right? The circle looks like a what? A circle, right? And what does the ellipse look like? Right, so a kind of elongated circle, right? So the difference between a circle and an ellipse is, in fact, if you have to define a circle, that's a nice question, Rihanna. What is? You're close to it. But if you have to define a circle is always what? Always round, all right. And it always has a what? A center and a radius. So it always has a center and a radius. What's the radius again? No. How? What is the radius? It's distance from the circumference to the center. Nice. But what is the special property of the radius? What's the special property of the radius? It's always what? All right. Let me ask it different. Right. So the circumference is always equidistant from the center, correct? Right? And the circumference is always the same distance from the center anywhere on the circumference? Right. If you had to define the ellipse now, what should I say the ellipse is? Huh? No. Locus of all the points, that's the definition kind of a locus. Right? But what is an ellipse? If you had a guess, what's the shape of it? Does it have a radius? Does it have a radius? Not really. Because, right, you have more than one. So what you will notice there is that the distance from the center is not the same. Okay? It's not the same. It's very little. And then we'll talk about why. And then when the parabola, you kind of know it from quadratics. Okay? The parabola could be shaped like that, or the parabola could be shaped like this. Okay? All those are parabolas. But it's based on the conditions, right? Right. I just want to go over some things. If you know it already, just screenshot it. If you want to write it down, go right ahead. All right? So because it's a straight line, I just want to give you the straight line rules from Form 1, right? These are your Form 1 straight line rules. Yeah. If you know them already, you can ignore them, right? Distance between 2 points, midpoint, gradient, parallel lines are equal, and so on, right? I'll use my Form 1, sir. I'll send these slides in a group, right? I'll send these slides in a group, so you'll have them. I'll send them all together as a PDF. Right? But if you don't recognize any, just copy them down. What we know about perpendicular gradients again? Product is -1. It was the first time you hear that in your life. Write it down. Shivish, write it down there. Perpendicular lines, the product is -1. Write this down here, right? You should know the rest. How do you find the equation of a line? Y is mx plus c, find m and c, right? Yeah, we know that. Amen. Shivish, we know all that. I just have to make sure you know all that. All right. Circles. I want to go over Form 5 circles. Right? We will be doing past papers on this, so let's write down everything here, right? So a circle, the general equation of a circle is x minus a squared plus y minus b squared is r squared. Yeah. The center is AB and the radius is r. Okay? And then there is the expansion of this. there is the expansion of this that looks like this. Okay? So as equation, write it down. Kind of circles, right? We now kind of start. What's that? Hurry up. Copy it down from here. Circles. Right? Copy it down from right there. I can project this before you go and talk to you, right? Right? Those who do the project, just stay back for 5 minutes after class, right? Right? So that's the general form of the circle. And then if you expand that out, then you will get this form here. The handwriting is not the best, right? But we'll make. So if you see the next form, x squared plus y squared plus 2fx plus 2gy plus c, then the center is minus f minus g, and the radius is that. F squared plus g squared minus c. This one is like a general. Okay? And there's a next thing that we need to remember. Sometimes they ask us, you gotta remember this from Form 5. They like to ask you to find the equation of tangent, right? And the tangent is always a what? A straight line, right? And it's always perpendicular to the radius. So in order for you to get the equation of tangent, you need to get the gradient of the radius, right? And since they are perpendicular, you use this rule here. -1 over the gradient of the radius. Okay? And then you use the formula to find the equation of tangent. All right, make a note of that. Copy it down. Plenty of the old past papers on this will be asking simple things like this. So we'll do a couple of those before we go into anything hard. Okay. Quick question. Suppose I wanted to get the equation of the normal. What's that, Zaria? What's the normal? That's just it right here. So really and truly, the normal is perpendicular to the tangent. So it's like just drawing a line out here. Right? So the equation of the normal is the equation of the radius. Okay? Copy that down. No. If they ask you to find the equation of the normal at a point, it's simply the equation of the radius at that point. All right? So that was some of the Form 5 stuff, right? Right here, two quick examples. We're not doing these. I'll give you 2-point passive, but that's not right. So if you look here, they ask you to find the center and the radius of x squared plus y squared minus 4x plus 6y is 2. What they did, they compared to the, what is called this form again? You'll call it general form? General, okay. So you compare it to the general form. All right? You compare it to the general form and find f and g. That's okay? And then how do you find radius? You use the formula, square root of f squared plus g squared minus c. All right? So that is an example from what you would have done in Form 5, right? You want to copy it down? Go ahead. Okay, so you just compare it to the appropriate form, right? All right. The part I would like you to try for me is find the equation of the tangent at 3, 1. Right? So at some point on this circle, you know the center, find the tangent at that point 3, 1 for me. Okay? So go back to what we did a little while ago. You know what the center is. This same equation here. Find the equation of tangent is. Let's see what you get. Find the equation tangent. so remember the steps. Find the equation quick. Remember the steps, right? Find the greater the radius, then negative reciprocal. Right, put a message for help on WhatsApp. Work it out. Hmm? Looking at it. Right, so remember the first step, right? Find the greater the radius. What is center again? The center was 2 minus 3, right? Find the greater the radius, then reciprocal. What's the point you're going to use to find the equation? 3, 1 or 2 minus 3? 3, 1, right? Must be a point on the line, right? So you can pin a message in your chat as well. It'll give you a summary. Like I'll try to pick up on what you write and what you do and give you a, but don't be so accurate, but yeah. But I thought you know how to use it, so you wasn't paying attention. So yeah. But try it next time, I'll let you. All right, nice. So what you all got for the gradient? Quarter. It wouldn't be minus a quarter. Minus a quarter. Yeah, listening. The product have to be equal to -1, yeah. So you remember the gradient of 1 is 4. And the next gradient is that. So when you carry the 4 here is -1. Or you could just use what? Negative reciprocal, right? Flip over the 4 and change the sign. Okay? So the gradient for the radius is minus a quarter. Right? And then plug it in the equation and you all got what? Plus 7 and 4. Nice. Huh? Sorry? Right? I just multiplied by 4 and get the answer, right? Trouble? Huh? Got it? Trouble? You sure? All right, so that is your equation, right? Well, I'm killing and then login online, so. Where? No, the answer. Caitlin, sorry. Okay, so that is a quick review on how to do this, right? For your right answer. What's that? What? I bet I have the shrink. Shrunk. All right, nice. I don't have all that. I think I stopped at 19 or something. Right. There are some quick things that I want to talk to you about, right? Here's what happens sometimes. Sometimes you will get a circle. Can I move this way? Sometimes they will ask you to find the equation of a circle, right? But in finding the equation of this circle, all they're going to do is give you 3 points, P, Q, and R. How you'll get the equation of the circle? Ignore my diagram. They're wrong, right? So suppose I gave you something like this. Suppose I gave you a circle. Let me get a nice little circle here for you. A looking circle-ish, right? Right. And I said, well, Shivish, help me out here. Find the equation of this circle, right? But all I've given you is a point here, a point here. What's the point of that? So you have P here, you have Q here, and you have R here. Why can't I erase the equals? Oh, right, yeah, I remember. Right, question. How do I find the equation of that? How do I find the equation of that circle? Gradient. All right. So let's go with something a little bit long, but something we could probably do. And we know the general form. The general form is x squared plus y squared plus 2fx plus 2gy plus c is 0. You still looking at the question, Brittany? What's she explaining this? Right? So your equation will look like that. That's okay? So everything will be P, R, and P. What? What is that, Ariane? P, R, and PQ? Or see what you're saying, see what you're trying to say. All right. That's the next method I'm going to show you. So if you look here, right? If you look here, we need to get this equation, right? But in order for us to get the equation, Divish, what we need? We need F, we need G, and we need C. Okay? But we have 3 points on the circle. So this point has an X and Y value. This point has an X and Y value. This point has a X and Y value. Any ideas what we could do? 3 unknowns, right? So how many equations we need? 3. Any idea how to get those 3 equations? So you can take the point P, put it in here. That will give you 1 equation. Take the point Q, put it in here. That will give you a next equation, right? And take the point R, put it in here, and that'll give you a third equation. And then you solve them and then you solve the 3 equations simultaneously to find F, G, and C. That's method 1. Okay? It's plenty. But take a look at method 2. And which one you find is plenty. Actually, just make a note of this, method 1. The subheading is finding the equation of a circle. Finding the equation of a circle given 3 points only. Right? Make a little sketch of this. They didn't give you anything. They didn't give you the center. They didn't give you diameter. They didn't give you any of those things. Wait, I now see Emily Miss Larry. Oh, the outside Emily, sorry. All right, so the first method is to plug in the 3 points into the general form and get 3 equations and you solve it. That's method 1, right? Right, let's take a look at method 2. Method 2, to me, method 2 just as long, huh? Watch method 2 here. Right, that's basically what Arian was trying to say, right? So here's what method 2 is. Method 2, the first attempt is to get the center. So what they did is they found 2 equations. They found P and R. They find equation P and Q. And then for each of those lines, they found the perpendicular bisector, right? So they found the perpendicular bisector here, and they found the perpendicular bisector here, right? My diagram not drawn to scale, right? And then they solve those 2 equations. Let's call them L1 and L2. They solve those 2 equations simultaneously. And where they meet is the center. Huh? You find the midpoint of the 2. Yeah. Okay. So that's method 2, right? Method 2 is to find PQ, PR, perpendicular bisectors, and then solve them simultaneously. I think I have that written down here for you. Not the best in the world, but. Right, just make another L1 and L2 are perpendicular bisectors. Once you have the center, what you can do after that? Well, find the radius and then find the equationary circle. All right. After you have the center, you can use that to find the length of the radius and then the equationary circle. All right. Online, are you okay there? Emily, Ishmael, are you okay? Right, remember we're missing one class in February, so we could have class on that day or we could carnival. Right? Or we could double up one of the days, right? Right, we could decide. Yeah. I'm gonna put some numbers in it, Ishmael. It's basically substituting P, Q, and R, getting 3 equations and solving them simultaneously. Right? I'm gonna put some numbers into it now and we'll do what? All right. So method 1 is plug in P, Q, and R, 3 equations and solve. Method 2 is to find the perpendicular bisectors of 2 lines connecting the points and then solve them simultaneously. Okay? I just find out what Windows is running. PC. Huh? What? Yeah, what Windows is this running? Huh? 10? Final. Oh, okay. 10. Okay. And it have 11 or 12 out now. 11. 11, yeah. One of them giving trouble. Both of them giving trouble. I'll go back to E3. It not run the camera properly. Huh? Oh. I don't know. I had to get this camera working, so I had to find out later. Huh? So I'm looking at. All right. So let's try one, right? No, forget it. I'm gonna give you one here. All right. So I'll give you 3 points on a circle. Let's see if we could follow all these steps, right? Let's see if we can follow all these steps and solve it. Hold on, I'm gonna get one from here that will work out nice. So let's see if we can find the equation. Let's see if we can find the equation of this circle given. P is 2, 3. Q is 5, 6. And R is 8, 3. Right? I will do method 1. And let's try method 1 and solve it now. Method 1, yeah. Feel free to use method 2 if you want. All right? Huh? Any method you want to use. I am going to use method 1. Right? So method 1, I would like you to substitute all the points in x squared plus y squared plus 2fx plus 2gy plus c is 0. Right? You substitute all the points in there and you will get 3 equations that we're going to solve. Right? And I'll show you the principle behind solving 3 equations, right? Yep. Get them quick. Get them quick. Find Q and R. hurry up, get all three equations quickly. Right, substitute P, Q, and R. Right? When you're solving simultaneously, right? What is always try to do? Eliminate a variable, correct? When you have two variables, you're trying to eliminate to get one. So if you have three, what you'll do? Try to eliminate one of them, right? Try and eliminate F, G, or C. Based on how your equation's looking, which one you think is the best one to eliminate? C, very good. Once you eliminate C, you can figure out F and G. Okay? Try that there. Get your equations, let's see how it looks. All right, so you have your three equations there. Right, so you want to eliminate C. So how we can eliminate C, Brian? Very good, right? So one of the ways to eliminate C is you can subtract, let's say, equation 1 from 3 and 2. Or you can make C the subject in equation 1 and substitute. Anyone could work, right? But I will do 2 minus 1. And then I will do 3 minus 2. Sorry, 3 minus 1. Anybody lost online? Ishmael, you getting through? Kalia, Samira, you all okay? All okay here? Samira? All okay? Yeah? All right, solve it out. Solve it out. 2 minus 1. Let's make sure you do that part right. 10 minus what? 4. I got 6. 12 minus 6. I got 6G. Then the C will cancel. Minus 61 minus 13 is how much? Minus 48. Nice. Everything has 6's and I can just divide it out. Yeah, if I divide by 6. Let's just make sure you don't have to multiply it back. Yeah? Oh, look again. Look at, you can just do 3 and 1, man. Anyway, F plus G is equal to minus 8. Right? Let's call that equation 4. You'll recognize what happened when you substitute 3 and 1. Sorry, minus 3 and 1. Yeah, you just get an F. So it worked out real nice there. 16F minus 4F is 12F. 6G minus 6G is 0. C minus C is 0. Minus 73 minus 13 is positive. That's minus 63. Why is it looking wrong? Oh, 60. Yeah. Thanks. Minus 60. So we know that F is equal to minus 5. Right? What you all got for G? Minus 3. Yeah? Solve for G and then solve for C. I'll define the short line next one. No? So you have to find the equation of the perpendicular by. That's all? And you have to solve simultaneously, okay? Wait, all right. Yeah, in this case, very good. In this case, that was helpful. Yeah. What you got for C? Anybody work out C? C is 9. Okay, nice. So we have the equation, right? I can't fit it in there, but we have the important things, F, C, and G, right? Actually, I can write it here for you in blue. X squared plus Y squared plus 2fx, so that'll be minus 10. Minus 10x minus 6y plus 9 is 0. All right? Are you confused about? How I get F? I just substitute F into an equation 4. And then I substitute it back into equation 1. Substitute it back into equation 1. F and G. All right. So that is a quick example. And in case you see something like that, what to do, right? Are you okay with that? Copy it down. Right. So that's something slightly new, right? Something else that's a little bit new is sometimes we have to take a circle and write the circle in a parametric form. So write it in a different form in terms of theta probably. Any ideas how to do that, Azaria? I feel like you do. Right? So we need to find a way to take a circle and write this circle in a parametric form, right? In terms of theta in this case. Everybody okay online? Right? Method 2 is just to follow the steps, right? You can try it out and see if you like method 2. Should get the same answer. Right, those who finish head up parametric oh, somebody got C as 25. Huh? Oh gosh, I just substituted. Hold on there, Ishmael. Somebody else got 25. Let me just check it out just to make sure. Amanda got all in, say nothing, Amanda. We would have moved on and we'd have get the wrong thing. Somebody that watches live and then say, we The answer is 25. Huh? Oh, that's good. C is 25. Check it back from now, please. So C is minus 13. Minus 13. Plus 20. All G again. G is minus 3. Plus 18. So that's 5. Yeah, 25. Grand G is set them up, man. Yeah, anyone you could work. 1, 2, 1, 2, or 3 could work. Yeah, look at do it on top there for you in blue. I had no more space now, so I put it for you in blue. I had no more space underneath. Change what? Oh, yeah. Change 9 to 25. The thing Azaria here, she paying attention. Good job, Azaria. What's Shivish? Right, true. That's what they're doing on the boy. I don't know. All right. So that's the way you solve this, right? Now we want to figure out now how to get that parametric equation. Do you remember what's parametric? When you have an equation in terms of a next variable. What is called x squared plus y squared plus 2fx plus 2gy plus c. What type of equation is that? Beginning with C. Beginning with C. Cartesian. When you have x and y, it's called the Cartesian form. All right? So let's take a look at how to write the circle in a parametric form, right? You see now there? Out in lessons, now out in no south anyway. Now we're talking about out in south. All right, so what is here? So what is here, right? Let's say I gave you a circle and I gave you those. Looking okay, looking confusing. All right. I'm gonna start it over. So what is here? Let's say I gave you a circle, right? Right? And on the circle, I'll give you a few things. I'll give you the center. Let's call the center AB. Let's call the center AB. And then we have a point all the way here, P. Let that point be XY. All right? I want to show you something here on the axis, right? Let's pretend it looks something like that. Something like that. So I want to show you something here. What is called this length here? AB to P is what? Radius. Nice. So we know that, right? Let's draw down a line here. This value is A, correct? This value is B. Are you okay with that? Yeah? Pay attention. Right? This value here is what? X. What? That value is X. And this value here is Y. Are you okay with that? Nice. So we're going to try to introduce a new variable now. Let's call the variable theta. All right? So I'm going to create this triangle here. I'm going to try and draw it in blue to highlight it a little bit. Here and here. It's a right angle triangle, correct? Here is what? Here's theta. You're okay with that? What is the opposite length there? What is this opposite length here? Sorry, y minus? Very good. That's y minus b. This whole thing is y, this little piece is b. So this piece here is y minus b. That's okay? Right, should be checking. Your chance to shine here. What's this length here? What's this length underneath there? The adjacent length. Same thing we just used to figure out y minus b. What would it be? Oh, to there. X minus a, right? I mustn't say that about the boy. The boy is smart. X minus e. All right, x minus e. So that line there is x minus e. Everybody okay with that? So quickly, what is sine theta? What is sine theta? Opposite over r. Are you okay with that? So if I rearrange that, can I get an equation for y? Yeah? Y is equal to b plus r sine theta. Are you okay with that? What is cos theta? Cos theta is adjacent over hypotenuse, right, Sarah? You okay there? So therefore, x is what? X will be a plus r cos theta. And there you have it. This and this is the parametric equation of a circle. Okay? So if you have x and y in that form, you have a parametric. Okay? Copy it down. No, AB. Every center is 0, 0, then A and B is 0 and 0. Right? What I gave you is the general form, regardless of what A and B is. Okay? Right? You don't have to prove it, but you have to be able to watch an equation and know it's a circle. Right? Actually, you can actually work it backwards. Anybody remember how to go from parametric back to the equationary circle? How it is. So if I gave you y is equal, in fact, I'm gonna give it right now, make it think a little bit. First day, the brain fresh is first day of the week. First day of the week. All right, clear sharp. Copy it down, and I'm gonna give you an. I tell you that I fall asleep. Well, not too bad. They got to go and do the thing. Email, yeah. Two NMC. All right, so that's the way you get the parametric equation that is circle, right? With me, copy down the work, my dear. finish copy now. Let me give you an example so you don't want your phone. I'm moving slow. I'm gonna give you one. Probably I'm moving slow. Right? While you're writing, I want you to think about how we could go from the parametric back to the Cartesian. I think Scarlett have it already. I think Scarlett have it. So basically, here's what you're thinking about. How do I remove theta? Right? Think about it. How do I remove theta? Because parametric is where you introduce that new variable, right? So Cartesian is where I have to get rid of that variable. Right? So between Kaylin and Scarlett, one of them have it. How are we doing that? Think about it. I'll give you an example. Let's now. Finish? Let's take a look at something like this now. So I've given you an example, and I am giving you the parametric equations of a circle, right? It becomes a little bit harder when you learn the other parametrics because they will just give you the parametric and you have to figure out what it is, right? But suppose I gave you something like this. The x was the cos, right? And the y was the sine, right? Yeah. I know it. Yeah. So I need some help here. How do I obtain Cartesian? How do I get rid of theta? Right? Those are things that you will see on your example, possibly see, right? How do we obtain the Cartesian? Huh? Square it, okay, and then do what? Yeah. Right. So you can do that. Or you can do it, you can do a little bit easier. Step 1, you can find cos theta. Step 2, you can find sine theta. Step 3, you can substitute in cos squared theta plus sine squared theta is 1. And then magically the theta has disappeared. Do it for me. Right, so we need to get started getting some practice. There's some of you that didn't revise and didn't practice. Right, Mondays be here until 8 o'clock. Right, you have to come and take the old past papers and start practicing. Okay? Sorry, sir. Huh? Yeah, I can send you a video and then we can do some questions. Give you a video and then we do some questions and do it together, yeah? Yeah, but you have to do the first part of revise. Oh, I think, anyway, you want the module 3 handout PDF or print it? Or print it? Or like a print. Anybody else somewhere that is printing? I don't know anywhere again. And if I wait here, it will take forever to print up. Module 3. No? That can go down on that side because I really trust right so far. Right, go ahead, do it. Find cos theta, find sine theta, and substitute. Follow the steps. No, he's having things copy already. By Mr. Marlon. No, I want to photocopy a module 3 handout. So you all could write in it now. Or you can just use the PDF, it's uploaded. Oh yeah. Find cos theta, find sin theta. Right? What you got for cos theta, Brittany? Huh? I'll do it quick. I can do that mentally, but make cos a subject. What you all get? X minus 5 and 2, right? And then sine theta is y minus 3 and 2. And then when you substitute, you're going to get x minus 5 and 2 squared plus y minus 3 and 2 squared is equal to 1. Sorry. What was the difference between the 3 lines and the 1? Right. And what does equivalent mean? Can't solve it, can't move things across, right? Right? But you have an equal sign, you can move things and use computation laws, right? And if you square it out, you'll get x minus 5 squared, y minus 3 squared, and you have 4 underneath. So you can multiply everything by 4. And you'll get something like that. Yep. X minus 5 all squared, y plus 3 all squared, equal to 4. That is your Cartesian equation. Online? Are you okay there? Amanda? Kyra? Okay. Right, the other little things that we have to know about a circle, besides its locus, you don't have to expand it out. If you want, you can do it. I just wanted to get a Cartesian. So that was just removing theta. If you want to get it general and expanded, go right ahead. Right, the next thing that we had to be able to do is to solve two circles simultaneously, right? Solve a line and a circle simultaneously and so on, right? Right, one of the trickiest things that you will see in a circle is being able to identify its locus, right? But I'll do locus as an entire topic after we do the parabola and the next one. Sarah, you okay there? Finish? Shivish, copy down. What are you concerned about? I kind of skip a step. I forget you there. I shouldn't do that. Right? When you square everything, right? And then you multiply by 4. So yeah, brother Shivish. I won't do it again. All right? Are you okay there? All right. So that is where this equation came from, right? Once you see it in that form, you know you have a circle, right? The key thing, because an ellipse will look just like this, an ellipse will look just like this, except it will not have a R here. It'll have two different values, okay? Because it doesn't have a radius, right? So it's important that you can identify the circle from the ellipse. All right. You have to be able to go the other way around as well. Take the Cartesian and go to the next form, right? If I give it this, right? Now that you know that this is a circle, can you just watch it and figure out the radius? What's the radius? Huh? 10 or root 10? 10. Oh yeah, 10. The radius is root 10 or 10. You sure? Squared to get r squared. Right? So it's r. Yeah. Time myself up there too. R is 10. Root 10. Okay? Because remember the general form is r cos theta plus a, right? So the radius is this, and what's the center? Center is what? Center is -3, 2. They just rearrange it. Okay? Instead of -3 plus root 10 cos theta, they have it the other way around. All right? All right, nice. So that is the first thing about this circle. Do I show you the ellipse today, boy? Let's talk about the ellipse, right? Let me just talk about it, right? While it's in your mind. So what you say? What you will recognize, I'll do it over. What you will recognize about an ellipse, that it doesn't have the same distance around the circumference. The distance will change. So there is something called a minor axis and a major axis, right? The minor axis in this case is the parallel to the x, and the major here is parallel. So once you have the minor and the major, you just connect them up and you get the ellipse. All right? So we're going to focus on those things next day, right? That's the equation and thing. We'll do that next day. Right? But the people who do the SBAs with our school, hold on for 5 minutes, right? Well, you good, you do it already. Same thing you talk about today in class, right? Right? So those who doing the SBA, just hold on for a few minutes, right? Everybody else, you can log out.